Right, okay then, as promised, I've done a little test of the IP-M using Slaved motors, working with this new plug-in. Unfortunately, like I say, I haven't got a machine I can test it on, so I am building a machine at the minute, which is what we sat on, and it has got twin ball screws, but it's not set up for this system. It's got belt drive on it. So we've just got it bolted to the bench, sort of thing. Right, first of all, let me just say it works as in the movement and the sinking, the slaving. It works perfect, as you would expect it to do. Can't fault it. I can't make it loose sink. I've messed around, run it every which way but loose, and it sinks perfectly, no problems whatsoever. There is one negative: it only ohms to one switch. It doesn't ohm each motor independently, so effectively you can't use it for squaring the gantry up, which for some people won't be a big deal. It's not a big deal for me, because my opinion is the gantry should be squared to start with, and if you've got to bend it into shape, you've got a problem. But all things said, it still would be better if it could do it. The only thing we've got to bear in mind here now, though, is this is a beta version of the firmware, and it's still new, this feature, so it will be improving. Now, knowing what CSlabs are like and how good they are at with the software at correcting faults or any issues, and also at listening to what people want, like this is a good example. I've sent loads of emails and asked them many times why can't I have slaved the IP-M, why can't it do slaving, and I've had various replies, but they have listened, and I'm sure other people have done the same, and now we've got it, we've got the feature. So you can rest assured I'll be getting onto them about this, not doing each motor independently, and I'm pretty sure in the coming releases it'll get sorted out. I would hope it would anyway. So to me, it's not really a big deal. The main thing is it does keep sync, which is great, and you would expect it to with control of this quality, and that's something I just want to stress, how good these things are. I've used most motion controllers, the smooth steppers, USB and Ethernet version, the Pro Logic, Pure Logic controllers, USB CNC. I've used most of them now, and none of them can hold a candle to this, the CSlabs stuff, in several ways: performance, quality of the software, the plugin, and also right down to just the quality of the unit itself. Like these connectors, for instance, they're all good quality, nice size, so you can get decent size wires in there, good screws, they don't strip the threads out, they're just quality in general. And the fact you don't need a breakout board is an absolute massive plus in my opinion. It all mounts onto DIN rail, as you can see. All these connectors, as does the box, that's got a DIN rail fitting on the back. There's the other one. Basically how it's laid out, this is your block for the outputs, so all your motor outputs are on there. You've got general outputs down there. These are your analog outputs and analog inputs, so that's where your spindle speed control would come from. And if you wanted to override the spindle speed, we're using a pot or feed rate override. You've got two analog inputs on there, so you would connect up to that. And this side is basically all the inputs. And then on the unit itself, as you can see, you've got LEDs, status of the inputs and outputs. This just gives you the state of how it's working, the Ethernet and all this flashing means something. If you look at the manual, it tells you what it means. Basically that means it's working good, as does you've got same LEDs on the Ethernet connection. You've got an expansion module. If you use their MPG module, that's where it plugs in, and this is just your power. So, absolute top quality, can't fault them, and I've used most of them, like I say, and none of them really hold a candle to it, considering its price. To get anything near this in quality, motor smoothness, the performance you get from it, you will pay a hell of a lot more money. So they are good. The things I like about it is there's no breakout board required. All the inputs and outputs are 24 volt. Good noise immunity. The fact there's no breakout board is a massive plus in my opinion, because breakout boards are just a pain in the arse. So and when you connect that to some decent drives like these Lee Shiny M806s to some steppers with enough voltage, you get a really excellent system. These are the digital drives. It's an excellent setup. Anyway, enough balling up. Right, back to what we want to see. I'll just whiz them. As you can see, all I've done is just fasten a bracket to it, some brackets to the steppers. This was off a motorbike that's been damaged. I made a new one. I just cut it in half. They're not perfectly lined up. You can see there, they're dipping at an angle. That's because when I tighten this bracket up, the stepper's twisted. So, but it keeps perfect sync when it's moving. They come back to the same place every time. Huh? I'm not going over fast because I don't want to shake the bench to pieces, because we're not balanced with those things hanging off the end there. These are just the targets for the proximity switches. As you can see, I put 2 on, but that one's just not being picked up. It's working, the controller's picking it up, Mac's seeing the switch, but it's having no effect on how it works. Right, I'll just send it home so you can see it home. And I said, it works. The syncing of the motors and how it works is perfect. I've done a little bit of code. I'll run the code now so you can see. This code's going to whiz these backwards and forwards. It's going to pause in certain positions and then move 90 degrees. And at the very end, this arm will point straight up, and then it will ohm to the switch, which I will run. Sorry, I clicked on the wrong button. That was ohming it again. And that's it, it's gone home now. That's just a bit of code that I've shown you. That's about it really. I will run you through, quick run through the plugin that you get with it. Now there's 2 sides to the plugin. For anyone who doesn't know this, just about every external motion control card is controlled through a plugin with inside Mac. Now you have a general sort of front end that you see, which is in the plugin controller, and that's what you would. This is the information side, so it's sort of showing you the temperature of the unit itself, IP address, and other sort of voltage setups. But it's just, this screen is just really information, sort of showing you the inputs that are triggered, the analog inputs, so it tells you the voltage on the outputs, the voltage on the inputs. As you can see, you've got 2 analog inputs. and then just general debug information and expansion. If you've got any expansion modules, it tells you what is connected up to it. That's just the front end as such. Now the meat of the system is what I'm going to show you next, but first I'll just explain quite a big difference how the CSlabs works to just about every other motion controller out there regards setting up the motors, and how Mac standard procedure works. Normally when you're setting your motors up, you would go to ports and pins, you go to motor outputs, and you would put the step and the port pin numbers in there, and you would give it the port address that you're using, and you would obviously set your active highs and active lows for what you're needing. You don't do any of that with the plugin. None of this is used, none of these. You can put anything you like in there, they're ignored. The only thing in here that is used is the enable, so it turns the axis on and off. That is the only bit inside here that has any effect. Now how you choose the axis, so which pins relate to which axis, is done with inside the plugin config itself. So if you go to config plugins, and this is where you set the actual, you configure the plugin. As you can see, I've got various plugins inside working at the minute, and the one we want is that config, the CSlabs one. Now this is the actual plugin itself that we're going to configure. Now the standard IP-M plugin, this is the new area to it. This is general, to me this looks just the same as the IPS version, except there's a few bits missing from down there, and also the mode, the correction mode, and the geometry correction where it reports the error is greyed out. That's not being used. But other than that, it looks very similar to the IPS. I believe there's a bit more information on the IPS down there. It's been several weeks now since I last played with an IPS, so I'm not 100%, but it looks very similar. Now the way you designate the pins on these things to which axis is quite easy really. Each axis has got its own tab, so you can see we're on the X-axis, and at the bottom there, step and direction is done by a channel, so you've got channel 0. Now the X-axis is going to use channel 0, and channel 0 corresponds to the first two pins, or pin 1 and 2 of, well, 4 pins. The top ones are the positives, so that's step, direction positive, and the lower pin is direction negative, step negative, step positive, step negative, and that's channel 1. So the first 4 pins on the top and bottom runs is channel 0, and it follows suit, so that's channel 1, channel 2 and channel 3. And as you can see at the minute, I'm using the first 4, so I'm using channel 0 and channel 1. Now I've got X-axis as channel 0, and if I go to the A-axis, you'll see I've got that as channel 1. And if I go back to the X-axis, you can see I am slaving the A-axis to the X-axis, so they will work as one, and that's all there is to it. By default, channel 0 is X, channel 1 is Y. Now the reason I swapped it is because I'd already connected the wires up to the terminal block, and I didn't want to have to faff about disconnecting the wires. It was easy to just switch the channel over, and that's how you would switch your axis. So let's say you wired up and you realise you'd wired the wrong way around, you could just change the channel. So if you'd wired the Y axis to channel 0, you'd just swap them over in there, and that is it. It's that easy. You don't have to do anything. There's quite a bit of this goes off within the plugin, as in some of the features that are in Mac are are taken away from it and they're done within the plugin. Ohming is one side to it. For instance, normally within Mac, when you're ohming, you would go to General Config, and where it says Ohm Slave with Master Access and things like that, you would tick them or untick them depending on your setup. Now, none of that has any effect with this setup, so it doesn't work. It doesn't have any effect because the plugin takes control of all that, and quite a few features that Mac normally has are taken away from it and done within the plugin. The reason being, the plugin has to take control, and it does a better job, to be honest, in some cases. So that's really it. That's it. That is the setup, like I say. So as you can see, it works good. Okay then, I hope that helps somebody. I will at a later date connect up to a machine and actually have it move a machine. I just can't at the minute because I've nothing that I can use it on. So, but I'm sure I will do it at a later date, and I'll report back when I do. Alright then, cheers.